So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 270 and in this video we continue with our exercise. And like all time, I want that you read the question here, pause the video, try to answer as good as you can and then compare it with my answer. And by the way, there is no absolute correct answer. Our goal is still to understand this side here and later the original paper, so you don't have to ask anyone and understand it on your own. And let's get started. So it says here, describe important parts of a class. So pause the video, and of course I will not pause here and will go and answer it. So what is that? First of all, we see this this instruction here is bad. Why is this bad? It says here, describe important parts of a class. You can't, every class can be different and every class can have a different purpose. So which means every class can have different important parts. So this, to describe here an absolute perfect answer, it's not possible because it depends just on the class. That's the first part. The second part is, but we can still start with at least as a base part here. So we can say, okay, I know every class is different, every class have different requirements, but what are the base requirements of a class which is very important? And this one we can answer. Let's go down here to my section 3, and here I have answered something. Let's uncomment this one. First of all, you can say, you can start with a class needs a class declaration and a definition. Okay, that's very obviously every class has a declaration and a definition. But here you have to understand what this really means. What I mean with that. Here, let's start with this one here. What is this one here? Class PC. You see I create here a class and I call it PC. What is this? This is probably a class declaration. That's right. But here, careful. When we talk about declaration, you have to think also about where this declaration is made, how to use declarations, and yeah, something like that. Because we have not talked about header files right now. We will talk about header files when we finish classes, because then it makes sense. Then we know we can put, for example, this class declarations in header files. In our case here, for example, in my house here, this house class here on top, there is no really declaration. There is a declaration, but it's and the definition also, because we know if you provide this body here and all the stuff in it are considered as the definition of this class house. So first of all, class declaration, and then how to use this declaration and where to use. And what I mean with how to use and where to use this, what we learned so far is you should know there is something like called forward declaration. What is a forward declaration? For example, in this case here, when I have this example, this one is a forward declaration. And what is this one here? This one is the definition of the forward declaration. So here we have, for example, talk about now this forward declaration. And the forward declaration, I will not dive into much. You go here to this section here in this part, and there is forward declaration, how to use. So for example, we know, yes, we have here this syntax here. This attribute is optional. All right, this one is fine. And then what was forward declaration again? Let's repeat this fast here a little bit with examples so that we know it. A forward declaration makes the class name visible for use. For example, here in this example, they are using it in another class. They are using it actually here. You see the class vector is used here, but important is this class vector is just a declaration. There is no definition, and again, That's why a definition is very important, because the compiler needs this part here, this definition, which comes later. And that's why they make here a forward declaration. They say to the compiler, okay, this class matrix is using this class vector, but right now the compiler don't know the definition. That's why we make a forward declaration and say you can watch this definition later here. That was this example, one example, but there are more examples. This example we have not talked, that was this with the header file. So you can, that, and this is interesting here later when we talk about header files, because you can avoid including these header files, and there is other nice advantages as well for performance, compilation time. Where if you are not including header files, you have faster compilation times and something like that. But we will talk about this when we talk about headers. Let's go here down to this one. This one looks like, what was this? This is hiding. This is also interesting. So you can see the forward declaration here. We have here a struct as. This is just normal definition. Here's the struct as with definition. Here's the body. And here, this one is ignored, you can see. But here it's interesting. We have again the same name. Normally, when we see the same name, you should avoid this. This is a general rule. You should try to avoid this. It will be not possible to avoid it all time. But try in general avoid same names. This can confuse a lot of people, and you can see it can have here effects. For example, this one here is now a new forward declaration, and now if you use this one here like so, this here, because you have here a forward declaration, is now hiding this one here. So you are not using this s struct here on top, you are using this one here, and that is one reason why you should avoid same names here if it's possible. Because if you would name this here, I don't know, a real name, then this one would be clear that it's using this one here instead of using this one here. And yeah, but you see, this here is considered now as a forward declaration. Here you can see this one is using this forward declaration, even if it has not a definition, and later here, this one is the definition of this one here again. Okay, that's very important to note here. And there is also something that you have to use pointers and references, but read this forward declaration more in detail. We are going only fast over it. And here one more thing, let's go to this part here. This looks a little bit difficult. What I mean with difficult is here, that's very easy. You can see there's a class U, a forward declaration, because you don't see the definition right now. Okay, but now they are using namespace. Namespace is just another organization tool, I call it. So we are organizing the name so that there is no conflict, because most time you need a namespace to avoid conflicting names. If you are, let's say, using this word class U again, and indeed they are doing it here anyhow, and something like that, we have to see. So they are defining here, defining and declaring a namespace here. But important is this line here. That's a little bit difficult for, try to read not this one here. Try to understand this one here. That's not easy. So if you see what's happening here is, I read it now. It says here declares function ns. Okay, what? Ns is our namespace. Here is a function. Okay, but we never used a function with the word class, right? This is the first thing, which is a little bit strange. And the reason for that one is this elaborate type. We talked about this elaborate type a little bit. You can write this one here to distinguish it from other things, but I think but important here is not this elaborate type. Actually important is here that it is declaring a class, and that's why we have here the class. Careful, because here you are creating a class Y, this one, for this one, declaring a class T. This is this one here, and you are doing in this all together at the same time while you are declaring a function. And that is a little bit irritating, because normally, why I say irritating is, for starters, normally you are not doing this at the same time. I mean, if you would do this all step by step, class declare class Y first, declare class T first, and then use it in a function line by line, it would be really clear and easy to see. This one, careful about something like that. You have to train this one, and try to avoid it at a start, I would say, because if you make it line by line, it's more readable, fast understandable. And this one only still train this one here, because other people will use it like they here, and then you have to understand it. And remember, all time we have to understand it, even if you don't like it, because if there is a bug and they present us a code like this, yeah, that's a problem. Okay, let's continue. What we have here is then again here this class UF, and interesting here, this class elaborate type is referring to this one here. It should use nothing here in this one, it should use this one here. That's why it says here this one. And we have here pointers, and you can see here they are declared here. And again, you can use pointers here, but careful. This here, this pointer is just pointing to this one. If you want later, you dereference a pointer, which means, let's say you want to read out a value of this pointer, then this one here must be defined, because right now it is just declared, not defined. That's very important. That was so again about this this forward declaration. You can see this forward declaration, we have to talk about it again, but that's very important. And let's go on with our question. We are not finished, because we are still in important parts. The next part is this one here. So the question is, what is that? I told you this is our definition, but actually, you will not believe me, but this one is the absolute basic what you need for a class definition. And you could ask now, wait a minute, what use case has this one? I mean, if you are creating now an object of PC, there is no variables, no functions, nothing in it. What is the use case of this? And that sounds strange. Even we could make here an object of this class PC. Let's make it one. So let's go here to let's go here to question 3. Let's make a PC object. Let's call it PC, my PC something like that. You can see I can create this one. The problem is my PC object here, what I'm doing with that. For example, access specifier, nothing. Pointer, nothing. I can't do anything with it. So the question is, hey, this is total nothing worth, right? But that's not true. Even in C++, they found even for this case a use case. It's a very special cases now, which you have to figure out. But yes, you can find for this empty classes also use cases. And I will not go now deep and find for you these cases, because they are very special, and normally you would not make this. Normally you create a class, define variables, functions, or whatever in it, and then have it. But for our questions, like again, I'm describing here the important parts, and this one is the important part. You have a definition, it can be empty, and now I hope you realized here something in this one, and that is, even if this one is empty, it is not empty. What I mean with even is it empty, it's not empty, because you should know by now that the compiler is creating, when you create a class empty, the compiler is still creating here many things. And for, about this many things, we have discussed two things, and that is the constructor, the default constructor, and also a little bit about the destructor. So this kind of things the compiler will create even if we can't see it here. It is called implicit. Implicit means the compiler is doing it, and explicit would be if we are providing these constructors. And this is the thing what you have to consider when you see something like this. And actually there are more things what the compiler is doing, and I will refer here to the section of special member functions. This is here also in member functions, and this empty class what you see here, what I have provided, has actually these things here what you can read here as a special member function. This is the compiler which can create, in it says here under certain circumstances the compiler will create them, right? So the default constructor we have already discussed, and destructor we have already discussed a little bit. And now the which we have not discussed so far is the copy constructor, move constructor, copy assignment operator, move assignment operator, and this prospective destructor, which is actually, this destructor is just like this one almost. The only difference is here you can define more destructors, and later with overload resolution it will be chosen one. And yeah, we have to talk about this one as well. But you see, our empty class here, it's not in real empty. And yeah, I think that's the real super basics which you can where you can start with this little code here. And but in general, again, for question number 3, when I asking you this kind of question, it depends on the class, on your class, what you are creating is important parts, of course. And this one I forgot to show you. When we go here to this part here, you can see when we go here to the class section, what else a class can contain. A class can contain almost everything, and you can see here all these things what you can put in a class, which we have, some of them we have discussed, some of them not. And yeah, that's the problem. Class can be really big and so on, and it depends in the end on your need what it's important. But again, that's the super basic which you should know by now, and then you build up all the other things. All right, with that said, I stop here the video. If you have any questions or any suggestions, like all time, write in the comment section. See you in the next video. Have fun, never give up, and bye.